Shake Table Lab by Gabbie, Doty, and Ali DiGiorgio. Prior to the actual build, we had to create a diagram that displayed the dynamics of the tower. Ali and I created the base and decided the desirable length. We did this for every layer of the tower. As you can see here, this page displays a photo of the first step to our build, the base. In order to create a sturdy tower, there has to be a sturdy base. Ali and I taped 4 straws together to create a square for our base. On this page, there is a display of another photo. This time, more progress has been made. Ali and I taped 2 straws together and added the posts to each end of each corner of the tower. We connected those straws with 2 more straws to make the posts longer. This addition was made so we could keep a more sturdy tower, and it is less likely to fail on the shake table. As you can see in this photo, we have added more straws and tape. When Ali and I were coming up with ideas for the tower's diagram, we decided that adding crossbeams in between stories was the best way to go for this build. We have also added some construction paper to the first floor so the sandbags wouldn't fall through. Here we show the dynamics of the tower after building it. In the end, our tower turned out to be 86.36 centimeters tall. Our base was 19.5 centimeters wide, and from the beams to the base of the first floor turned out to be 19 centimeters. The second floor was 21 centimeters wide and 18 centimeters tall. Some things that were different from the original sketch were the height of the roof and the height of the first floor. The rest of the tower was almost exactly the same as the original sketch. Before we could actually put our tower on the shake table, Ali and I had to test out how strong it was and make sure it could withstand the weight. We put 2 beanbags on each floor. Our tower was able to withstand the weight pretty well, and there wasn't much we needed to improve on. As you can see, we doubled the amount of straws just below the construction paper in case an incident did occur where the tower couldn't withstand the weight. We did this for both floors with construction paper. I would have to say our strongest part was the part that Ali and I made stronger. Doubling the straws just below the construction paper would really help out the tower hold the weight of the sandbags. Our weakest parts were the cross beams because most of the straws had to be bent in order to get the right size to fit across. We could have doubled the amount of straws on the cross beams, but that would have taken a lot of straws to accomplish, and we just didn't have that many. While being lectured on tape by Mr. C, he told us specifically not to create a rat's nest. I don't think Ali and I made a rat's nest, but the place where we used the most tape was in this picture. For extra supplies, Ali and I used construction paper. We went for a strict theme of red and black paper. Take a video.
Oh God, there he goes.
He looks stylish.
He's just flexing to show his muscles.
While the tower was shaking, many sensor graphs were recorded. In these graphs, it displays the x-axis, y-axis, and z-axis of the shaking. X meaning side to side, Y meaning back and forth, and Z meaning up and down. Our building was able to support 10 sandbags. Our building failed in the cross beams in the front right here because they're not able to support the weight. If I could have changed anything about our building, it would have been to add a support beam through the center of our building so it could support all the floors. I enjoyed being able to channel my inner creativity by building a roof of my own, and I also very much enjoyed the process of building it.
Our building was able to support 10 sandbags, each weighing 250 grams. Our building failed at the bottom, where the straws weren't strongly connected and they were unable to hold the extra weight added by the sandbags. If I could change anything about our tower, I would make the bottom a lot stronger so it would be able to hold the extra weight. I would probably make stronger cross beams to be able to hold it. I learned that in order to have a building that could hold an extra weight added by the sandbags and the shaking of the earthquake, you need to make a very strong bottom to be able to support the extra weight. I enjoyed this lab because I was able to have fun and learn about the different styles of buildings and learn how to make an earthquake-proof building.